We will be learning how to deal with or how to work with addition word problems. We're going to look at the keywords that indicate an addition in a word problem, look at the steps for solving word problems, and then we're going to walk through some examples. The following keywords, these are the keywords that identify addition in a word problem. You have words like add, you have words like altogether, you have spend, both, total. You also have a word like sum. Sum also indicates an addition. Total indicates an addition. Combined indicates an addition. Plus. So these are some of the important keywords that indicate an addition. And the steps for solving these word problems, we need to first indicate what we know, what we don't know, what the question, and when we say what we don't know, we're looking at what the question is asking us to solve, and identify any keyword that indicates addition, and then we'll perform the addition. So the first question, Benjamin has 24 apples, Donald has 69 apples. How many apples are there if they both combined their apples? So what do we know? Let's start from that. What do we know? We know Benjamin's apples. We know Benjamin's apples. We also know Donald's apples. And what do we not know? So what we don't know is the number they have together. So we don't know the number of combined apples. So now let's see, is there a keyword here that leads us to addition? Combined leads us to addition. So what we're going to do now is we're going to add 24 and 69. So 24 apples, 69 apples, we add them together. So 4 plus 9, we have 13. So we write a 3 and carry a 1. 1 plus 2, 3 plus 6, 9. So we have 93 apples. So we can say all together, they have 93 apples. Next question. Tom grew 18 carrots, Jessica grew 38 carrots, and Mary grew 41 carrots. They worked for 27 days on the farm. How many carrots did they grow in total? So let's start with what we know. What do we know? Tom's carrot, Jessica's carrots, Mary's carrot. And we know how many days they worked on the farm. Days worked on the farm. So what do we need to know, or what do we not know? Total number of carrots. So now what we need to figure out is what keyword leads us to an addition or to a mathematical operation. Here it says, how many did they grow in total? So we're going to add these numbers together. So we have 18 carrots, 38 carrots, and 41 carrots. So you may ask, what about 27? 27 is the number of days they worked on the farm. It has no relationship with the carrots in question. It has no relationship with the unknown, which is the total number of carrots. So that's why we're going to ignore it when we add. So we have 8 plus 8, that's 16 plus 1, 17. So we put a 7 here, we carry a 1. 1 plus 1, 2. 2 plus 3, 5. 5 plus 4, 9. So we have 97 carrots in total. So 97 carrots in total. Final example. There are 12 oak trees currently in the park. Park workers will plant 23 more oak trees today and 18 more oak trees tomorrow. How many oak trees will the park have when the workers are finished? Okay, so let's look at that. What do we know? Okay, current number of oak trees, okay, number planted today, and then number planted tomorrow. Okay, so what do we not know? We don't know the total number of oak trees. Total number of oak trees. Now this is a tricky one because it requires some imagination. So here you're seeing a situation where you have 12 oak trees already. Now you have 23 that are going to be added today, and then tomorrow 18 are going to be added again. But you want to find out how many oak trees will there be when everything has been done. So you can see that's almost like saying how many would you have all together or in total. So we're going to add those numbers together. So we have 12 oak trees. We have 23 oak trees. And then we have 18 oak trees. Now we're going to add this together. 2 plus 3, 5, plus 8, 13. We put a 3, bring up a 1. 1 plus 1, 2. 2 plus 2, 4. 4 plus 1, 5. So we have 53 oak trees. Alright, in this lesson, we're going to look at how to solve word problems that have to do with comparing fractions. We're going to start by outlining the steps that are ideal when you're trying to solve word problems that have to do with comparing fractions. And then, in usual fashion, we will walk through some examples together following those same steps. Now, when you have word problems that have to do with comparing fractions, you have to examine a few things. One of the things you want to do is if you have mixed numbers in the word problem, you always want to first go ahead and convert the mixed number to improper fractions. And if you have fractions that have different denominators, you want to get the least common multiple of each of those denominators and then create equivalent fractions for each of those improper fractions, or it could also be proper fractions in cases where it's proper fractions, but you want to create new fractions with common denominators so you can use the numerators to compare the value of those fractions. So now we're going to look at some examples together. In a reading test, the students are expected to answer 3/4 of the questions correctly to earn a passing grade. Thomas answered 5/6 of the questions correctly. Did he earn a passing grade? So we have 3/4 and 5/6. So we have 3/4, 5/6. So the first thing we're going to do here is to find out what the least common multiple of 4 and 6 is going to be. 4 is 2 squared. 6 is 2 multiplied by 3. And so the LCM is going to be 2 squared multiplied by 3, which is going to give us 4 multiplied by 3, and that's 12. So the next thing we're going to do is to convert each of these fractions to an equivalent fraction with a denominator of 12. So 3/4 now becomes, we're going to multiply 4 by 3 to get 12, and we multiply 3 by 3 to get 9. So you have 9/12. And then 5/6, we need to multiply 6 by 2 to get 12, and then 5 by 2, we have 10/12. So what we're saying here is that you need 9/12 to pass, but Thomas got 10/12. So therefore, Thomas actually passed the test. So Thomas earns a passing grade. So Thomas earns passing grade. So he's going to earn a passing grade. The next example, Maria, John, Brianna, and Lucas competed in a car race. If their times are 1.5 hours, 6/5 hour, 7/6 hour, and 1/3 hours, accordingly, arrange the driver's completion time in increasing order. So we have, first thing we're going to do is convert every mixed number to an improper fraction. So 1.5 is going to be 1 multiplied by 2 plus 1 over 2, which is going to be 2 plus 1 over 2, and that's going to give us 3 over 2. The second one is 1/3. So 1/3 is going to be 1 multiplied by 4 plus 3 over 4, which is going to be 4 plus 3 over 4, and now we have 7 over 4. The next thing we're going to do now is we're going to find the LCM of all the denominators. So we have 2, 4, 5, 6, and then we need to find the LCM. So it's 2 to the power of 1, 4 is 2 squared, 5 is 5 to the power of 1, 6 is 2 multiplied by 3, so 2 to the power of 1, 3 to the power of 1. So the LCM is going to be 2 squared multiplied by 3 multiplied by 5, which is going to give us 4 times 3 times 5, which is 12 times 5, and that's going to give us 60. So now our fractions are 3 over 2, and then we have 6 over 5, we have 7 over 6, and we have 7 over 4. So what we're going to do now is we're going to convert this to equivalent fractions with a denominator of 60. So we're going to multiply 2 by 30, and then 3 also by 30. This is going to give us 90 over 60. Then 6 over 5, we're going to multiply 5 by 12 and 6 by 12. So that's going to give us 72 over 60. And then 7 over 6, we're going to multiply 6 by 10. And then 7 by 10, we're going to get 70 over 60. And then we're going to multiply 4 by 15, 7 by 15. We're going to get 60 in the denominator, 105 in the numerator. So our fractions are now 90 over 60, 72 over 60, 70 over 60, and then 105 over 60. So here we're trying to arrange the driver's completion time in increasing order. So that is from the smallest to the largest. So we have 70 over 60. Then we have 72 over 60. We have 90 over 60. And then we have 105 over 60. So now let's replace them with the original fractions. So 70 over 60 is 7 over 6. 72 over 60 is 6 over 5. 90 over 60 is 1.5. And then 105 over 60 is 1/3. So now this is arranging the completion time in increasing order. So now, who was the fastest driver? The fastest driver is the driver that completed in the shortest amount of time. Fastest driver is the one that drives 7 over 6 hour, which ends up being Brianna, because Maria has this time right here, John has this time right here, Brianna has this time right here, and Lucas has this time. So fastest driver is Brianna. Next example, Milton and Dharma went to pick grapes in a vineyard. The grapes Milton picked weighed, yeah, that's wrong. So it's weighed 29 over 4 pounds, and those Dharma picked weighed 7 1/3 pounds. First thing we're going to do here is convert 7 1/3 to an improper fraction. So 7 1/3 is going to be 7 multiplied by 3 plus 1/3, which is 21 plus 1/3. That's going to give us 22/3. The next thing we're going to do is to find the LCM of 3 and 4. So we got 3, we got 4, LCM. 3 is 3 to the power of 1, 4 is 2 squared. LCM is 2 squared multiplied by 3, which is 4 multiplied by 3 gives us 12. So now we have 22/3, and then we have 29/4. So let's convert 22/3 to a fraction with a denominator of 12. So 22/3 is equal to, we multiply 3 by 4 until we multiply 22 by 4. That's going to give us 88/12. And then 29/4, we're going to convert this to a fraction with a denominator of 12. So we multiply 4 by 3, we multiply 29 by 3. This is going to give us 87/12. So who picked more grapes? So you can see that 88/12 is greater than 87/12. So whoever picked this, so 88/12 corresponds with 7 1/3 pounds. So 7 1/3 pounds is greater than 29/4. So now, what we're going to say here is that Dharma picked more grapes. And then the final example, Riley wants to create a vegetable garden in his yard. He needs 23/4 feet of wood to create this garden. If he finds 5 2/5 feet of wood in his storage, does he have enough wood to create the vegetable garden? The first thing we're going to do here is convert 5 2/5 to an improper fraction. So we have 5 2/5 is 5 multiplied by 5 plus 2/5, which is equal to 25 plus 2/5, and we now have 27/5. Next thing we're going to do is find the LCM of 4 and 5. 4 is 2 squared, 5 is 5 to the power of 1, so LCM is going to be 2 squared multiplied by 5, which is 4 multiplied by 5, and that's going to give us 20. So now we have 23/4 here as our fraction, and then we have 27/5. So we're going to rewrite each of these fractions as a new fraction with a denominator of 20. So we're going to multiply 4 by 5 to get 20. So we multiply 23 also by 5. This is going to give us 115/20. And here we're going to also multiply 5 by 4 so we can get 20. And then we multiply 27 by 4. This is going to give us 108/20. So how much wood does he need? He needs 115/20 feet, but he has 108/20 feet. So therefore, Riley does not have enough wood. So that's what this means. He needs to get more wood if he's able to create the vegetable garden. Let us look at solving word problems that deal with equal ratios. We're going to take a quick look at reviewing equal ratios, and then we're going to go ahead and solve some examples that allow us to apply the concept of equal ratios. So in this review, what is the value of x in 2 over 11 equal to 12 over x? So to get this, we're going to multiply 2 by 6 to get to 12. So we also multiply 11 by 6, which is going to be x is equal to 11 multiplied by 6. So x is equal to 66. The other approach we have is what I call the cross product approach. So we're dealing with the cross product approach. This is going to be equal to 12 over x. So what I'm going to do here is we're going to have a cross product. What that means is that we have 2 multiplied by x equal to 11 multiplied by 12. So we're going to divide both sides by 2. So you can see that we cross this out. Now we divide 2 by 2, 1, 12 by 2, we have 6. So x is equal to 11 multiplied by 6, which is 66. So in these examples we're going to walk through, I'll use one of the methods. So let's look at some examples. The ratio of boys to girls in an elementary school is 5 to 7. So boys to girls is 5 to 7. If there are 350 boys in the school, how many girls are there in the school? So let's look at this. Number of girls in the school. So let's say number of girls, we call that x. So what we have here, our ratio equation that we're going to create here is 5 over 7 is equal to 350 over x, where x is the number of girls in the school. Now I'm going to use the cross product method here. So we have a cross product. So what that means to us is 5 multiplied by x is equal to 350 multiplied by 7. We divide both sides by 5, and we have 350 divided by 5, we have 70. So x is equal to 70 multiplied by 7, which is 490. So what this means to us is that we have 490 girls in the school. Next example, the ratio of teachers to students. Ratio of teachers to students in a college is 3 to 25. If there are 2,250 students in this school, 2,250 students in this school, so how many teachers are expected to be in this school? So number of teachers in this school, so let's call that x, number of teachers, that is going to be our x. So we have x to the ratio of 2,250. So now we're going to have our equation 3 over 25 is equal to x over 2,250. So I'm going to use the cross product approach here. And so we have 3 times 2250 is equal to 25 times x. We're going to divide both sides by 25, and 25 goes in 25 one time, so 25 divided by 5, we have 5. 2250 divided by 5, let's do that. 2250 divided by 5. 22 divided by 5, we have 4 times. 4 times 5, we have 20. So we have 2, we bring down the 5 here. 25 divided by 5, we have 5. 5 times 5, we have 25. And then we got a 0 here. So this is just going to be 0. So we have 450 here. You divide 5 by 5, 1. By 450, we have 90. So x is equal to 3 multiplied by 90, which is going to give us 270 teachers. Our final example. The recipe for cornbread requires that the ratio of flour to eggs, so flour to eggs, is 5:3. If 12 eggs are used when making the cornbread, how much flour will be needed for the recipe? So, amount of flour is going to be our x. So we have, in this case, we have 5:3 is equal to x to 12. So let's create our equation. 5/3 is equal to x over 12. I'm going to use the other approach. So we have 3 multiplied by 4 is going to give us 12. So to get the value of x, we'll also multiply 5 by 4. So this is going to be 5 times 4. This is going to give us 20. So we can say 20 units. Most likely it'll be, we can say 20, most likely it'll be 20 cups of flour. In this lecture, we're going to look at how to create a system of equations from word problems. So we're going to look at creating the system, solving the system, and then interpreting the solution of the system. So in this example, it reads, a farmhouse shelters 14 animals. Some are horses and some are dogs. Altogether, there are 36 legs. How many of each animal are there? So we have 14 total animals. 14 animals. So let's use H to represent horses and D to represent dogs. So that means that we have H plus D is 14. That's the total number of animals we have. And then we have 36 legs. 36 legs. Horses have 4 legs. So 4 times H represents the number of horses. So that would help us identify the number of legs for the horses. And then 2 times D would represent the dogs, and this is going to give us 36. So our system is H plus D equal to 14 and 4H plus 2D equal to 36. Now, we have two approaches we can use here. One approach is to divide this second one by 2. So if we divide by 2, we have, so let's divide this by 2, we have 2H plus D equal to 18. So now let's solve the system. So H plus D equal to 14, 2H plus D equal to 18. So I can see it's easy to eliminate the D. So we have 2H minus H equal to 18 minus 14. So H equal to 4, and then D equal to, well, let's say H plus D equal to 14, 4 plus D equal to 14. So let's put that over here, 4 plus D equal to 14. So we'll subtract 4 here, subtract 4 here. So D equal to 10. So what this means here is that in this farmhouse there are 10 ducks and 4 horses. So the 10 ducks will account for 20 legs and the 4 horses will account for 16 legs. When you add them together, you should see 36 legs. Second problem. Daniel spent $340 on books. Math books cost $50 and science book cost $70. If he bought a total of 6 books, then how many kind of each did he buy? Okay, so we have math books. We represent that with M. Let's say math books for M and science books for S. So math book plus science should give us 6. But then we're told that he spent $340. So a math book costs $50. So 50 times M will tell us how much he spent on the math books, and 70S will tell us how much he spent on the science books. That should give us $340 here. So I'm just going to use substitution. So if I solve for M in the first equation here, M is equal to 6 minus S, and I'm going to substitute that into the second equation. So I'm substituting that in here. So 50 multiplied by 6 minus S plus 70S equal to 340. So 300 minus 50S plus 70S equal to 340. So 300 plus 20S equal to 340. We subtract 300 here and we subtract 300 here. So 20S equal to 40. So we divide by 20, divide by 20. So S is 2. So we have 2 science books, but we're also told that M is equal to 6 minus S. So 6 minus 2 gives us 4. So what this means to us is that there are 4 math books, 2 science books. Now a final example. A class used cars and vans to go on a field trip because all of the buses were already in use. They used 10 vehicles to go on the trip. So we have 10 vehicles. Each car holds 3 students and each van holds 12 students. If 48 students went on the trip, how many of each type of vehicle did the class use? So they have 10 vehicles. So let's represent cars with C and vans with V. So there are total of 10 vehicles. So C plus V equal to 10. A car holds 3 students. So there are 3 students in each car and 12 students in each van, and a total of 48. So I'm going to use substitution. So I'm going to solve for C here. So this tells me that C is 10 minus V. So let's substitute that back in here. 3 10 minus V plus 12V equal to 48. So we distribute. We have 30 minus 3V plus 12V equal to 48. So 30 plus 9V equal to 48. We subtract 30 here, subtract 30. 9V is 18. Divide by 9. Divide by 9. So V is 2. And then C is 10 minus V, which is 10 minus 2, which will give us 8. So this means that there were 8 cars and 2 vans. That's really how you deal with word problems that lead to systems of equations. We'll be studying subtraction word problems, and our focus will be on identifying subtraction keywords, look at the steps for solving the word problems, and then looking at how to solve examples. So here are the keywords that we want to pay attention to when we look at subtraction. We're looking at less or less than, we're looking at fewer, we're looking at decrease, we're looking at give away or gave, keyword difference, change, left, how many more, how much more. Those are the kind of keywords that you want to look out for in a subtraction word problem, or in a word problem that leads you to a subtraction. So with word problems, we want to always identify what we know, what we don't know, then we want to identify the keywords, and then we're going to perform the subtraction. Let's look at some examples. So Mary decided to sell all of her old books. She gathered up 44 books to sell. She sold 19 books in a yard sale. How many books does Mary have left? So let's see, what do we know? So here are the things we know. We know the number of books she gathered, number of books gathered. We also know number of books sold. So we're looking at the number of books sold. And we want to know which, because we don't know that right now. Unknown is number of books left. Okay, so now we want to figure out if we can identify a keyword that leads us to a subtraction. It says, how many books does she have left? Left or leftover. So she started off with 44 books and she sold 19 books. So we want to find out how many books she has left over. So we start from the right hand side. 4 minus 9, we can't really do that. So we're going to go to the left hand side, the neighbor on the left hand side. We go to the neighbor on the left hand side and beg for 1. So borrow 1 from that neighbor. The neighbor is left with 3, but the one that we have now makes this number 14. 14 minus 9, we have 5. And then 3 minus 1, we have 2. So Mary has 25 books left. Let's look at that. Mary has 25 books left. Let's look at another example. Martha has 473 pennies in her piggy bank. Simon also has a piggy bank but has 164 pennies in his piggy bank. How many more pennies does Martha have than Simon? What do we know? Let's start from there. We know pennies in pennies Martha has. We also know the number of pennies that Simon has. But what we don't know is, unknown here, is how many more pennies Martha has than Simon. Okay, now we need to identify a keyword that leads us to subtraction, if any. So we're looking for how many more. This is the keyword that leads us to a subtraction. So we have 473 pennies from Martha and 164 pennies from Simon, and we want to subtract to find the difference, to find how many more. So 3 minus 4, not doable, so we go over to 7, we borrow 1, we're left with 6 over here, this becomes 13. 13 minus 4, we have 9. 6 minus 6, we have 0. 4 minus 1, we have 3. So this means that Martha has 309 more pennies than Simon. Final example. Dan grew 44 watermelons and 37 turnips, but the rabbits ate 16 watermelons. How many watermelons does Dan have left? Okay, so what do we know? What we know is Dan grew, we have 44 watermelons. We also have 37 turnips. We have 37 turnips. And we also know that the rabbits ate 16 watermelons. Okay. Now, what do we not know? What do we not know? We don't know how many watermelons Dan has left. So we don't know how many watermelons Dan has left. Okay, so we're going to pay attention to these because we want to find out what's the keyword that is going to lead us to a subtraction. The keyword here is left. So we have 44 watermelons because the focus of the question is on watermelons. So we're focused on watermelons, so we have 44 originally, and the rabbit ate 16, so we have watermelons. Okay, so now we subtract 4 minus 6. We can't really do that, so we're going to borrow from this 4. This is left with 3, and now we have 14. 14 minus 6, we have 8. 3 minus 1, 2. So we have 28 watermelons left. So let's write it. Dan has 28 watermelons left. Now the important thing to know here is we did not use turnips in any of our work because the question doesn't really focus on turnips. It's more focused on the watermelons. Now we're going to look at rate word problems. We're going to focus on distance, speed, and time problems, and then we're going to look at work rate problems. So the relationship between distance, rate, and time is given as this. Distance is speed or the rate multiplied by the time. And then rate is the distance divided by time. So distance is speed multiplied by time. And then we can deduce the others. We can say speed is distance divided by time, and time is distance divided by speed. Now let's look at some word problems. 2 cars started from the same point at 9 a.m. So they are traveling in opposite directions at 20 and 40 miles per hour respectively. At what time will they be 330 miles apart? So let's kind of try to diagram this. So we have a starting point. Let's call this point A. One car goes in this direction, let's say 40 miles per hour. Another car, and the second car goes in this direction at 20 miles per hour. We want to find out at what point will they be 330 miles per hour apart. So let's look at the distance. Distance is given as speed multiplied by time. So there's going to be a consistent time here. So for we can say this is car 1 and this is car 2. So for car 1, the car 1 would cover a distance of, let's say car 1 distance is 20 miles per hour multiplied by time, which is t. Car 2's distance is going to be 40 miles per hour times t. So to get the distance apart, we're going to add the distance covered by car 1 and the distance covered by car 2. And at that point, we'll be able to determine how far apart they are. So distance covered by car 1 is 20t. Distance covered by car 2 is 40t, and they are 330 miles apart. So 60t is going to be equal to 330. So we divide by 60 on both sides. And so we have T is going to be 5.5 hours, or we can write this as 5 hours and 30 minutes. Now, we want to understand if this is actually valid. So let's multiply 5.5 by 20. So we have 110 miles this way, and for card 2 you have 220 miles this way. So you can see that this right here is 220, this here is 110. So you can see that this car right here and these two cars are about 330 miles apart. But the question is not done. It's asking at what time. So what we're going to do is we're going to add the number of hours, the duration here, to 9 a.m. so we can know what time it would be, 5.5 hours from when they started. So this is going to be 9 a.m. and then we add 5.5 hours to this. So this is going to give us 1430 hours. And of course, we can convert it since it's in AM PM. So we're going to subtract 12 hours. So it's going to be 2:30 p.m. So at 2:30 p.m., if the cars drive at these speeds, they will be exactly 330 miles apart. So John left home and drove at a rate of 45 miles per hour for 3 hours. He stopped for lunch, then drove for another 3 hours at a rate of 55 miles per hour to reach his destination. How many miles did John drive? So let's look at the first distance he covered. Let's look at first part of his journey. He drove 45 miles per hour. So distance is speed multiplied by time. So 45 miles per hour multiplied by 3 hours. So he drove 135 miles the first time. And then for the second part of his journey, so second part, we also know that distance is speed multiplied by time. Second part, he drove 55 miles per hour for 3 hours, which gives us 165 miles. So how many miles did he drive is going to be the sum of the first part of his journey and the second part of his journey. So total distance is going to give us 135 miles plus 165 miles. When you do this addition, you should get 300 miles. So we're going to look at this rate of work problem. It takes 1.5 hours for John to mow the lawn. Linda can mow the same lawn in 2 hours. How long will it take John and Linda working together to mow the same lawn? So for John, it's 1.5 hours for the lawn. For Linda, it's 2 hours. So what we're trying to do, the first thing we're going to do is, what is John's rate of work? So how much of it can he do in 1 hour? So for John, the whole lawn, so let's do this. One lawn takes 1.5 hours. So we want to find out how much of it he can do in 1 hour. So we're going to have 1 over 1.5 of the lawn. So this is the fraction of the work he can do in an hour. So this is going to give us 2/3 of a lawn per hour. Okay, for Linda, she can get through one lawn or one piece of lawn in 2 hours. So we want to find out her rate of work. So this is amount of work she can do in 1 hour is going to be 1/2 of the piece of lawn. Now we want to find out if they work together, what is their rate of work. So what we're going to do with that is we're going to add up John's rate, which is 2/3, and Linda's rate, which is 1/2. So when they work together, their rate of work is going to be, let's do the fraction here. So this is going to be lowest common denominator of 6. So this is going to be 6, and this is going to be 4/6 plus 3/6, which is going to be 7/6. So if they work together, they can get through 7/6 of the lawn in 1 hour. So if they can get through 7/6 of the lawn in 1 hour, how long will it take them to get through one piece of the lawn? So 7/6 of a lawn can be done in 1 hour. So the whole lawn is going to be 1 divided by 7/6, which is going to be 6/7 of an hour. Now let's look at another example. A tank can be filled by pipe A in 4 hours and by pipe B in 6 hours. When the tank is full, it can be drained by pipe C in 8 hours. If the tank is initially empty and all 3 pipes are open, how many hours will it take to fill up the tank? So let's start with pipe A. Pipe A requires 4 hours. So what is the rate of work? The rate of work for pipe A is, so you have one tank, so 4 hours are required to fill one tank. So in 1 hour, pipe A fills 1/4 of the tank. Let's look at pipe B. Pipe B requires 6 hours to fill one tank. And so in 1 hour, pipe B is going to be able to fill up 1/6 of the tank. Now we have pipe C. Pay attention to what pipe C does. Pipe C is a draining pipe, so that's very important to note. So it requires 8 hours to drain one tank, and so in 1 hour it can only drain 1/8 of the tank. So now when they are all working together, so pipe A plus pipe B, but then pipe C is draining, so it's going to be minus. So we have 1/4 plus 1/6 minus 1/8. This is when they work together. So if they're all working together, this is what you should see for the effort in 1 hour. So let's simplify this. So the least common denominator here is going to be 24. So I'm going to have 6/24 plus 4/24 minus 3/24. So this is going to give us 7/24. So when they work together, 7/24 of the tank can be done in 1 hour. So this is showing us that 7/24 of the tank is filled in 1 hour. So we want to find out how long is it going to take to fill up the tank. So the tank is represented by 1. So one tank is going to be 1 divided by 7/24. So it's going to give us 24/7, which is 3/7 hours. So if these 3 pipes are working together, it's going to take 3/7 hours for the tank to be full. And take note, it's also taken into account that we have pipes A and B filling up the tank and pipe C draining the tank. So after 3/7 of an hour, the tank will be completely full with all these pipes working together. Let us learn how to solve multiplication word problems. We're going to look at the keywords that indicate multiplication, and then we'll look at the steps for solving word problems, and then go ahead and solve some examples. When we're looking at the multiplication keywords, I would say keywords in a word problem that lead you to a multiplication. You're looking for words like product, times, each before the question, per, every before the question, one before the question. But let's go ahead and just walk through some steps on how we go through this, and then we'll look at examples later on. So how do we solve multiplication word problems? We need to write what we know, what we don't know, identify multiplication keyword, and then perform the multiplication. Now, let's look at some examples. So Sandy has 13 red balloons. Mary has 8 times more red balloons than Sandy. How many balloons, red balloons, does Mary have? So what do we know? Let's start taking note of what we know. What we know is that Sandy has 13 red balloons. And Mary has 8 times. Mary has 8 times Sandy's. What don't we know? What we don't know is how many balloons Mary has. What's the key word here? We're looking at times. Times means multiplication. So what we're going to do here is we're going to multiply 13 by 8. 3 times 8 is 24. We have 4 here. We'll put a 2 up here. 1 multiplied by 8, we have 8 plus 2, 10. So this is 104. Therefore, we can say Mary has 104 red balloons. There are 48 calories in each candy bar. How many calories are there in 23 candy bars? Okay. Let's look for what we know. What we know is number of calories in each candy bar. Also, we know that there are 23 candy bars. What don't we know? What we don't know is number of calories in 23 candy bars. So how do we know what to do? Is there any keyword? We say each, because we have in each candy bar. So we're going to perform a multiplication. So we have 48 calories in each candy bar multiplied by 23. So 8 multiplied by 3 is 24. We have a 4. We carry up a 2. 4 multiplied by 3 is 12. We add 2 to that. We have 14. Then we put a 0 out here in the ones place. 8 multiplied by 2 is 16. We write a 6 there and we carry up a 1. 4 multiplied by 2, 8 plus 1, we have 9. So we now add all this together. This is 4 plus 0 is 4. 4 plus 6 is 10, so we write 0 down and carry up 1. 1 plus 1, 2 plus 9, we have 1104. So we have 1104 calories in 23 candy bars. Final example. Keith has 26 books. Tom has 8 times more books than Keith. How many books does Tom have? So what do we know? We know that Keith has 26 books. We also know that Tom has 8 times more. What don't we know? What we don't know is the number of books Tom has. So to do that, we're going to multiply because of the keyword times. So we'll multiply 26 multiplied by 8. 6 multiplied by 8, we have 48. So we have an 8 there, carry up a 4. 2 multiplied by 8, 16 plus 4, we have 20. So this is 208. So Tom has 208 books. We will be learning about division word problems. We're going to look at the keywords in the word problems that indicate that a division needs to happen. Then we'll look at steps used for solving word problems, and then we're going to solve some examples. So here are the keywords that indicate a division may be required. So you look at words like quotient, equal or equally, half, remainder, goes into, split. And then, so these are the keywords you want to take note of when you are dealing with, when you're going through a word problem to see if it's a division word problem. But now let's look at how we go about solving word problems. We need to write what is known, what is not known. We will need to see if there's a division keyword available, and then we perform the division. Let's look at some examples. So Fred goes out to lunch with Sally and Nancy. The total bill came to $27. They decide to equally split up the bill. How much will each person have to pay? So the keyword here is equally. So what do we know? Let's create this. Known is cost of the bill. Unknown is what each person pays. What each person pays. We have a keyword equally, so we know we're dividing. So what we end up doing here is each person pays 27 divided by 3, because we have $27 and we need to split it equally among the 3 friends who went to lunch. So this is going to be 9. 9 times 3 is 27. So each person pays $9. Let's look at another example. Sarah has 1,488 pieces of Skittles. She wants to give her 24 friends the same number of blue balloons. How many will each person get? So we look at here the same number. This you can also say equal here. So what do we know? We know number of Skittles. Number of Skittles. What do we not know? Unknown is what each person gets. Okay, so we have 1,488 Skittles, 1,488, and we want to divide by 24 to figure out what each person gets. So 1 divided by 24, not going to happen. 14 divided by 24, not going to happen. 148 divided by 24, not going to happen. So let's try this here. I'm going to do something here. 24 times 1 is 24. 24 times 2 is 48. 24 times 3, 72. 24 times 4 is 96. 24 times 5 is 120. 24 times 6 is 144. 24 times 7 is 168. So here we can see that 148 falls between 144 and 168. So we're always going to take the lower number. So 6. 6 times 24 is 144. We subtract. So we have 4 here, 0 on the other side. Bring down the 8. 48 divided by 24, we have 2. 2 times 24, we have 48. We subtract, we have a remainder of 0. So therefore, each friend gets 62 Skittles. Final example. A restaurant sold 1,800 hamburgers to 150 customers last week. How many hamburgers on average were sold to each customer? So we look at each is a keyword for division. So what do we know? We know number of hamburgers sold, number of hamburgers sold. What do we not know? Let's say unknown. How many each customer bought? What else do we know? We know number of customers. Okay, so we want to find out how many hamburgers each customer bought. So we have 1,800 hamburgers and we have 150 customers. So I'm going to do what I did in the previous question. 150 multiplied by 1 is 150. 150 multiplied by 2 is 300. 150 multiplied by 3 is 450. 150 multiplied by 4 is 600. Okay. So let's go ahead and divide. 180 divided by 150, that is 1. 1 multiplied by 150, we have 150. We subtract 0, 3. And then we bring down the 0 here. So we now have 300. 300 divided by 150, that's going to give us 2. 2 times 150 is 300. This is 0. So each customer was sold 12 hamburgers. 12 hamburgers. Now this lesson will cover proportion word problems. And we're going to first introduce proportions and then we're going to deal with some proportion word problems. A proportion is the name given to a statement that two ratios are equal. So here, for example, A over B, which is this fraction, is equal to C over D, or A to B equal to C to D. Now, an important thing to know here is that when two ratios are equal, their cross products are also equal. The cross product is when you multiply the numerator of one fraction by the denominator of the second fraction. And so here, when you have A over B equal to C over D, then that means that A times D is going to be equal to C times B. Or here, A times D equal to B times C. So it's pretty much what we're trying to show here, that when two ratios are equal, then their cross products should also be equal. Now we're going to solve for x and we're going to use the cross product to solve for x. So because we have this equal to sign here, what we know is that 3 times x must be equal to 24 times 5. So we divide both sides by 3 to get the value of x. And so we have x equal to, we divide 3 by 3, 1. 24 divided by 3, 8. 8 times 5, so this is x is 8 times 5, which is equal to 40. So x is equal to 40. In this case, we're going to also use the cross product. So 6 times 42 is equal to 7 times x. So we divide both sides by 7. to get the value of x. So 7 divided by 7, 1. 42 divided by 7 gives you 6. So x is equal to 6 times 6, which is 36. So x is equal to 36. Now let's look at some other word problems. Sylvia has a typing speed of 55 words per minute. So she has 55 words for every minute. How many minutes will she type 1,100 words? So we want to find out 1,100 and want to find out how many minutes she can type 1,100. So we're going to apply the cross product here, and we're going to have 55 times x equal to 1100 or 1100 times 1. So we divide both sides by 55. So this becomes x on this side, and then 1100 divided by 55. Let's pick 110 divided by 55. That gives us 2, and then we have 0. So she's going to type 1,100 words in 20 minutes. So a farm worker picks 5 baskets of strawberries in 20 minutes. 5 baskets of strawberries in 20 minutes. How long will it take to pick 18 baskets of strawberries? So we're going to use our cross product here. So let's use our cross product right here. So what that means to us is that we're going to say 5 multiplied by x equal to 18 multiplied by 20. So we divide both sides by 5, and we have x on this side. 5 divided by 5, 1. 20 divided by 5, 4. So this is 18 multiplied by 4. So x is going to be 72 minutes. This question states that a piece of cable 5 inches long, weighs 12 pounds. How much will 24 inches of the same cable weigh? How much will 24 inches of the same cable weigh? So we're going to use our cross product. 5 times x equal to 12 times 24. You divide by 5, divide by 5. So we have x is equal to 288 divided by 5. Let's do that right here. 288 divided by 5. So we have 5 here. 28 divided by 5 gives us 5. 5 times 5 is 25. We subtract. We have 3. We bring down the 8. 38 divided by 5. That should give us 7. 7 times 5 should give us 35. We have a 3, a remainder 3. And so we're going to put a decimal right here. Introduce a 0. 30 divided by 5 is going to give us 6. 6 times 5 is 30. So that cable is going to weigh 57.6 pounds. So in Rhode Island, 17 out of every 50 women give birth by C-section. So 17 out of every 50 women give birth by C-section. If 12,000 women gave birth last year, how many of the births were by C-section? So we want to find C-section right here out of 12,000. So we're going to do our cross product again. So 17 multiplied by 12,000 is equal to 50 multiplied by x. We're going to divide by 50. Divide here by 50. So we have 0 crosses out here, 5 crosses out, and then we have 240. So we have x is equal to 240 times 17. Let's do that right here. 240 times 17. 0, 8, 16. We put a 0 over here. 0, 4, 2. And then we add this together. We have 0, 8, 6 plus 4, 10. And then we have 4. So we have 4,080 C-section births. So, proportion word problems. We apply what we know from ratios to proportions and use them to solve word problems. We will go over basic word problems and an introduction to word problems. Here's what we're going to focus on. Basic word problems leading to one-step equations, two-step equations, and multi-step equations. And with this, we're going to walk through some examples. Generally, for word problems, you want to identify the known and unknown terms. We want to assign a variable to the unknown term. We want to create an equation and then solve the equation. Solving the equation should give us the value of the unknown term. So let's look at this example here. We have, the example reads, there are 9 maple trees currently in the park. Park workers will plant 5 more maple trees today. How many maple trees will the park have when the workers are finished? So we want to find out how many maple trees the park will have. Okay, so we can say maple trees. Let's assign it a variable x. So x will be the value of what exists currently and what will be planted. So x equal to 14. So therefore, when the workers are done, we should have 14 maple trees. Okay, let's look at another example. So this example reads, Ellen has 2,080 Legos, but she has lost 17 Legos. How many Legos does she have now? So the number of Legos, let's use this, number of Legos is unknown, so we can assign that the variable x. So what we know from the question here is that she started off with 2,080 and she lost 17. So that's going to give us the number of Legos she has left. When you walk through this, 2080 minus 17 should give you 3620. So x is now equal to 2063. So this means that Ellen has 2063 Legos. Finally, let's try this one here. So Mrs. Hilt bought some foods to make a fruit salad. She spent $15.50 for a bag of apples, $30 for a bag of oranges, for a box of oranges, $27.25 for a bag of tangerines, and $8 on a bag of nuts. She paid the clerk with $100. How much change will Mrs. Hilt receive? So let's call, so the change Mrs. Hill gets is equal to x. So what we have here is that she has $15.50 and $30 and $27.25 and $8 plus an unknown value is going to give us $100. So first thing we're going to do is to get the value that she spent. So that's $15.50. This is $30, $27.25, and then $8. We're going to add all, and we should get 0.75. 5 plus 7, 12 plus 8, 20. We got 2 right here. So we have 3 plus 3, 6 plus 2, 8. So we now have $80.75 plus X equal to $100. So we're going to subtract $80.75 from both sides. So this is going to give us X is equal to 19.25. So what we now have is that Mrs. Hilt gets $19. Mrs. Hilt gets a change of $19.25. Another example here. There are 15 walnut trees currently in the park. Park workers will plant more walnut trees today. When the workers are finished, there will be 56 walnut trees in the park. How many walnut trees did the workers plant today? So X is number of walnut trees planted. It's planted. Okay. Now there are 15 currently, and there's a certain number that got planted, and that should give us 56 total trees. So what we're gonna do, so this is the equation that we have formed. Now we're going to solve the equation. Simplest way to do it is subtract 15 on both sides. So X equal to 41. So there were 41 walnut trees planted. Now let's take a look at two-step equations. In this question, we have the sum of 3 consecutive odd numbers is 105. What is the smallest of the 3 numbers? So let's look at what a consecutive odd number. Let's look at the series of consecutive odd numbers. 1, 3, 5. What we can see here is that this, right, the next number here is the previous number plus 2, and then the next number here, which is 5, is the previous number plus 2. So let's start off with the smallest of the consecutive numbers. So let's say the starting number, let starting number equal to X. So next number is X plus 2. Then the number after that the next number after that is going to be x plus 2, which was the previous number, plus 2. Okay, so what we now have is we're going to add all these numbers together and they should give us 105. So we have x plus 2 plus x plus 2 plus 2 here is going to give us 4 equal to 105. So we have x plus 2 plus x plus 4 equal to 105. So let's group common terms together. We have x plus x plus x plus 2 plus 4 equal to 105. So we now have 3x plus 6 is equal to 105. Now we're going to subtract 6 on both sides. So 3x equal to 99, and then we divide by the coefficient of x. So we now have x equal to 33. So that means that the smallest number, so what we have here is smallest number is 33. So now let's look at this question here. Mike bought 5 baseball trading cards to add to his collection. The next day, his dog ate half of the collection. There are now 34 cards left. How many cards did Mike start with? So we want to know how many cards Mike started with. So let's assign that a variable x. So x is number of cards Mike started with. So number of cards Mike started with. So here's what the equation tells us. So Mike had X cards and he bought 5 more, and the dog ate half of all he had, and now he's left with 34. So what we're going to do now is to get the number of cards he had left. So the first thing we're going to do is we're going to get rid of the fraction. The easiest way to do that is to multiply both sides by 2. So x plus 5 equal to 68. Now we want x equal to c, so we subtract 5 here and subtract 5 here. So x equal to 63. So Mike had 63 cards. Final example here is that Oceanside Bike Rental Shop charges an $11 fixed fee plus $7 an hour for renting a bike. Nancy paid $39 to rent a bike. How many hours did she pay to have the bike checked out? So we want to find out number of hours she had the bike, number of hours. Let's give that the variable x. Now there's an $11 fixed fee, so $11 plus $7 for every hour, so $7 for every hour is equal to 39. So we're going to subtract 11. So 7x equal to 28. Now we divide by the coefficient of x. So x equal to 4. So Nancy had the bike checked out for 4 hours. That's the answer to the question. Now we're going to multi-step equations. So this one states that John and Mary went strawberry picking. Mary picked twice as many baskets of strawberries as John. After Mary gives away 16 baskets, they have an equal number of baskets. How many baskets of strawberry did John pick? So our known is number of baskets John picked. Number of baskets John picked. So let's now follow the question. So that's going to give us our variable, which is our unknown, number of baskets John picked. So Mary picked twice as many as John, so Mary has twice as many. After Mary gives away 16 baskets, so Mary gives away 16 baskets. She now has the same amount, the same number as John. How many baskets of strawberries did John pick? So now what we're going to do here is we're going to always remember, when you're dealing with equations, solving equations, your goal is to get to x equal to c or y equal to c, where x or y are considered to be variables and c are constants, so they're just any number. Okay, now let's do one thing here. We're going to add 16 to both sides because we want x equal to c. You could do it so many ways here. So we have 2x equal to x plus 16. Now we can take out x from here. So x equal to 16. So therefore, John picked 16 baskets. John picked 16 baskets. Okay, final example. So Martha has 4 cupcakes and $6, and Dan has 2 cupcakes and $8. For them to have an equal value, Martha has to double hers and Dan has to triple his. What is the cost of a cupcake? So cost of cupcake, let's call that x. So let's look at Martha. This is what Martha has. Martha has 4 cupcakes, so that's going to cost 4 times x, and she has $6. What about Dan? Dan has 2 cupcakes and $8. So now we're told for them to have an equal value, Martha has to double hers, so she's going to double hers, and Dan has to triple his. Okay, now we're left with this equation. Now we're going to solve. The first thing we're going to do is to get rid of the parentheses. So let's distribute. 2 times 4x, that's going to give us 8x. 2 times 6 is going to give us 12. 3 times 2x is going to give us 6x. 3 times 8 is going to give us 24. Now we're going to subtract 6x from both sides. So that's going to give us 2x plus 12 equal to 24. And now we're going to subtract 12 from both sides. So 2x equal to 12. Now we divide both sides by the coefficient of x. So we have x equal to 6. So therefore, cost of cupcake equal to $6. Let us go ahead and solve systems of linear and quadratic equations algebraically. So that means using algebra. We're going to review linear quadratic systems, and then we're going to go ahead and look at the techniques for solving linear quadratic systems. So linear quadratic system is one in which one of the equations is linear and the other one is a quadratic. An example here, we can see this is a linear equation right here, y equal to 2x minus 3, and we have a quadratic, y equal to 3x squared plus 5x minus 7. Now here's how we're going to go about solving this linear quadratic systems. For the linear systems, we're going to rewrite in the form y equal to mx plus b, and for the quadratic equation, we're going to write in the form y equal to ax squared plus bx plus c. And then because we have y equal to in both equations, we're going to equate y equal to y, so mx plus b equal to ax squared plus bx plus c. The next thing we're going to do is group the common terms together, and then we're going to solve the resulting quadratic equation, get the value of x, and then substitute that back into one of the original equations we had in the system. I typically like to use the linear, but you can use the quadratic if you prefer. So let's go ahead and start working through some examples. So we want to solve y equal to x squared plus 3x minus 5, and then y equal to x plus 3. Now we already have these equations in the desired form, so what we're going to end up with is x squared plus 3x minus 5 is equal to x plus 3. Now we're going to group common terms, so we have x squared plus 2x minus 8 equal to 0. So we're going to factor this quadratic equation. So we have x plus 4, x minus 2 equal to 0. So x plus 4 equal to 0, which tells us that x equal to minus 4. We also have x minus 2 equal to 0, which tells us that x equal to 2. So I'm going to substitute these two values into y equal to x plus 3. So we have y equal to x plus 3. So x equal to negative 4, y equal to negative 4 plus 3, which is equal to negative 1. X equal to 2, y equal to 2 plus 3, which is equal to 5. So the solution to the system, so let's say solution, we have two solutions. We have negative 4, negative 1, and then we also have 2, 5. So this is the solution to the system. Let's take a stab at another example. So the first thing we're going to do is look at the forms, then the desired form. So we have x squared minus 4x plus 6 equal to x plus 2. So we're going to group common terms together. We have x squared minus 5x plus 4 equal to 0. So now we're going to solve this quadratic equation. We start by factoring that. So we have x minus 4, x minus 1. So x minus 4 equal to 0. So x equal to 4. We have x minus 1 equal to 0. Then we have x equal to 1. So now we're going to use y equal to x plus 2. So what that means is x equal to 4, y equal to 4 plus 2, which is equal to 6, x equal to 1, y equal to 1 plus 2, which is equal to 3. So for our solutions, we have 4, 6. We also have 1, 3. We have y equal to x squared minus 9x minus 18 and y equal to x plus 3. These equations are in the desired format, so we're just going to equate them. So we have x squared minus 9x minus 18 equal to x plus 3. So now we have, grouping common terms, x squared minus 10x minus 21 equal to 0. So here we're going to try to factor this, but before we factor it, let's look at the factors of 21, negative 21. We have 1 and 21. So negative 1 and 21. We have 1 and negative 21. We have 3 and negative 7, negative 7 and 3. So we have a situation here where we cannot directly factor this. So we're going to use the quadratic formula. So x equal to minus b plus or minus square root of b squared minus 4ac over 2a. So this is going to be minus of minus 10 plus or minus square root of b squared minus 10 squared minus 4 times 1 times negative 21 over 2 times 1. So this is going to give us 10 plus or minus square root of 100 plus 84 over 2. We have 10 plus or minus square root of 184 over 2, which gives us 10 plus or minus 2 square root of 46 over 2, which is going to give us 5 plus or minus square root of 46. So we have x equal to 5 plus the square root of 46. We also have x equal to 5 minus the square root of 46. Now we have told that y is x plus 3. So x equal to 5 plus square root of 46. Y equal to 5 plus square root of 46 plus 3, which is 8 plus square root of 46. X equal to 5 minus square root of 46. Y equal to 5 minus square root of 46 plus 3, which is 8 minus square root of 46. So solutions, we have 5 plus square root of 46, 8 plus square root of 46. We also have 5 minus square root of 46, 8 minus square root of 46. So this is how you would apply the algebraic method to solving a system of quadratic and linear equations.
Hello, my name is Lillian Akpe, the co-founder of Mathis Tutors. At Mathis, we are very passionate about helping students achieve their academic goals. We provide tutoring to students from elementary to college level in maths, English, language arts, science, and ACT, as well as SAT. Over the years, students that have enrolled in our program have seen improvement in their letter grade as well as their ACT and SAT scores. Due to the pandemic, majority of our courses are exclusively online. This summer, we have provided a lot of free courses, free online courses, and free resources to students to help improve their math skills. Our goal is to reach out to 5,000 students by the end of 2020. With your help, we believe we can achieve this goal. Thank you.
We're going to look at solving systems of linear equations by graphing. The first part of this lesson will look at how to graph linear equations, and then we're going to see the method for using the graphing method to solve linear systems. So generally, to graph an equation, you want to determine the x-intercept, so that is when f of x or y equal to 0, and the y-intercept when x is equal to 0. So let's try that with this graph right here, graph of f of x equal to 1. So we say f of x, or we can say y equal to 2x minus 1. So let's look at x-intercept. So y equal to 0. So it means 2x minus 1 equal to 0. So 2x equal to 1, x is a half. Then we look at the y-intercept. The y-intercept is when x is 0, so y equal to 2 times 0 minus 1, which is equal to minus 1. So what we're going to do now is we're going to look for this point on the graph. So x equal to 1/2, let's put that right about here. And then y equal to -1, so that is right about here. So now we're going to draw a line that joins those 2 points together. So we have a line that joins those 2 points together. So that is the graph of y equal to 2x minus 1. Now to solve a system, you're going to draw both graphs on the graph paper, and we're going to look for the point where both graphs actually touch or intersect. That would be the solution for that system. Now we're going to try that. So here we have x plus y equal to 7. So let's look at x plus y equal to 7. So for x-intercept, we have y equal to 0. So x plus 0 equal to 7. So x is equal to 7. Now let's look at y-intercept. For the y-intercept, x equal to 0. So 0 plus y equal to 7. So y is 7. So we have the point 7. So we have 7 right here. We have 7 here and we have 7 here for the first equation. I'm going to draw that in a green pen. We're going to use a green line to indicate that specific. So that's about the graph of x plus y equal to 7. Now we're going to look at x plus 2y. So we have x plus 2y equal to 11. Let's try x-intercept. This y equal to 0. So x plus 0 equal to 11. So x is equal to 11. And then y-intercept, x equal to 0. So 0 plus 2y equal to 11. So y is 11 over 2, which is about 5.5. So we're going to draw that in red. So 5.5 is right about here for y. 5.5 is right about here. And x is going to be about 11, which is, we don't have that on the graph, so we're going to try some other points. Let's look for the value of x when y is, let's try y equal to 1, y equal to 2, y equal to 3, and see what we get for the value of x. Y equal to 1, so we have x plus 2 equal to 11, so x equal to 9. Y equal to x plus 4 equal to 11, so x is 7. y equal to 3, x plus 6 equal to 11, so x equal to 5. So now we have several points we could use. We have the point x equal to 1, y is 9, so we have that point right there. X equal to 7, y equal to 2, we have that point right there. X equal to 5, y equal to 3, so we have this point right here. So now we're going to draw a line that joins those points together. So what we have right here is we have this point, we have this line that joins all these points together. And so therefore, what we see here is the point where the green line and the red line intersect is going to be the solution to the system. And so for us, that point is roughly the point 3, 4. So that is the solution to this system. Now we have another one to draw. So we have 3x plus 2y equal to 19. So 3x plus 2y equal to 19, and here we have x plus y equal to 8. So 3x plus 2y, look at the x-intercept, so y equal to 0. So 3x equal to 19, therefore x is 19 over 3. Let's look at the y-intercept. Y-intercept x equal to 0, so 0 plus 2y equal to 19, so y is 19 over 2. Okay, let's look at x plus y equal to 8. Let's look at the x-intercept. Y equal to 0, so x equal to 8. Y-intercept, x equal to 0, so y equal to 8. So the first thing we're going to do is we're going to draw a line for 3x plus 2y equal to 19. So let's look at the point. X is 19 over 3. So that's right about here. Y is 19 over 2. So that's right about here. So what we're going to do is we're going to draw a line that joins those 2 points together. So we start from here, and we draw a line that joins these 2 points together. And then we're going to draw the line for x plus y equal to 8. So we have x equal to 8 for the x-intercept, right about here. Y equal to 8 for the y-intercept, right about here. So what we're going to do now is we're going to draw a line that joins these 2 points together. From this graph, we can see that the point of intersection is roughly at the point 3, 5. So when x is 3, y equal to 5. Now we're going to look at two-step equations, and the key to two-step equations is that it requires 2 steps for you to get the value of the variable. So let's look at some examples. We look at 4x minus 3 equal to 5. So remember that our goal is to get to x equal to c, where c is a constant or a number. So the first thing we're going to do is we're going to apply the additive inverse, or we can call that the opposite of the number. So we got x here, and then we have a constant here and a constant here. Our goal is to make sure the constants stay on one side of the equation. So here we're going to add 3, which is the opposite of negative 3. We're going to add to both sides. So minus 3 plus 3, this crosses out, becomes 0. So 4x equal to 8. Next thing we want to do is apply the multiplicative inverse, or the inverse of the coefficient of x. quick reminder, the coefficient is the value on the left-hand side of x. So we're going to divide by 4, and then we're going to divide this by 4. So x equal to 2. Now let's look at one more example. 5x equal to 3x minus 4. Always remember our goal is x equal to c, or sometimes c equal to x. They mean exactly the same thing. So we're going to move the 3x to the same side as the 5x. So the opposite of 3x is going to be negative 3x. This is negative 3x. So we have 2x equal to negative 4. Now we're going to divide by the coefficient of x, which is 2. Divide this by 2. So x equal to negative 2. This lesson is about looking for the equation of a line, or determining the equation of a line using tables. We're going to look at first calculating the slope of a line, then we're going to examine the steps that we need to use to find the equation of a line. The slope is a very important component, that's why we go about that first, and then we're going to walk through about 3 examples together. So to calculate the slope of a line, we use the equation y2 minus y1 over x2 minus x1. Also realize that this will be the same if you have y1 minus y2 over x1 minus x2. The whole concept of this is rise over run. So that is the main thing we're trying to do here. So let's look at an example. Find the slope of a line that passes through the points negative 3, 7, and 2, 5. So what I'm going to do here is I'm going to make this my x1, y1, x2, y2. So here our slope is going to be, I always have this habit of writing out my formula first, y2 minus y1 over x2 minus x1. Now we can substitute. y2 is 5, y1 is 7, x2 is 2, x1 is negative 3. This is what I encourage all my students to do. When you have a defined method, it's actually more difficult to be wrong, because you can see the layout of how you're going about your math problem. So just take a look at this, just having this method here of having the x1, y1, x2, y2. It's easy to just substitute the values into the original equation. So 5 minus 7, we have negative 2. 2 minus minus 3, it's 2 plus 3. So now we have negative 2 over 5. And that's our slope in this situation. Next thing we're going to do here, we want to look at the steps that we have to follow to determine the equation of a line. First thing we want to do here is select any 2 points from the xy value pairs from the table. Then we will calculate the slope using the point selected. And we can select one of the points from step 1, or we can just select any of the points from the table. And then we'll use the formula y minus y1 equal to m. M is actually your slope right here, multiplied by x minus x1. And then we're going to write the equation in the form y equal to mx plus b. Now let's go through some examples showing you how to do this. So find the equation for the line represented by the table below. So we're going to do, first thing is we're going to select any 2 points. I like to make things simple. I'm going to select these points. So the points I'm going to select are going to be the points 0, 0, and the points 1, 3. Okay, so here's what I'm going to do. We're going to do our x1, y1, x2, y2. Next, we're going to look for the slope. The slope, I like to always indicate that it's represented by m, is going to be y2 minus y1 over x2 minus x1. This is going to be, y2 is going to be 3 minus y1 divided by x2, 1 minus x1. So this is 3 over 1, which is going to give us 3. So the next thing we have to worry about is our equation, which is y minus y1 is equal to the slope m multiplied by x minus x1. So because I have a point that is 0, 0, my point here is going to be 0, 0. Always try to make things as simple for yourself as possible. So we have, this is going to be our x1, y1. Y minus y1 is going to be y minus 0. Slope is 3, and then x minus 0. So this is going to be y minus 0, which is equal to be 3 multiplied by x. So this is y is equal to 3x. That is the equation of our line. And you can use this equation to test some of these points if you want. That's the way to verify. So if we look at, I'm going to do just for this example, but just note that you can use this for every example. So in this case, let's look at x equal to 3. So y equal to 3 multiplied by 3, which is 9. So you can see that this works out for, this equation works out for this table. Next example, find the equation of the line represented by the table below. First thing I'm going to do is pick 2 points. I like to always pick simple points. If you don't like dealing with negative numbers, you can always pick the points that don't have, but it doesn't really make a difference. I like to pick any point that has a 0 in it because it just makes things a lot easier. So I have 0, negative 1, and then I have 1, 1. So here's how we're going to go about it. We got x1, y1, x2, y2. So now let's go ahead and get our slope. Slope m is going to be y2 minus y1 over x2 minus x1. y2 is 1 minus y1 minus negative 1. x2 is 1. x1 is 0. So this is going to give us 1 plus 1 over 1, which is 2 over 1. That gives us 2. The next thing we're going to do now is we're going to pick a point because we're going to look for, we're going to use that point to find the equation of the line. So I have y minus y1 equal to m, which is our slope, x minus x1. I'm just going to pick the point 1, 1 as my point. You can actually pick 0, negative 1 if you desire, but I'm just going to use 1, 1. So this is going to give me, let's label the point. We have x1, y1. So our equation, let's substitute our points and our values. So y minus 1 equal to slope is 2, and then we have x minus 1. So let's simplify now. Y minus 1 equal to, we distribute 2x minus 2. And so now we're going to add 1 to both sides of the equation. So y is equal to 2x minus 1. So that is the equation of our line. You can go ahead and try a few points and see if it works, but I think it will. Actually, let me do one, just so that you can see how to do this. So we're going to pick this point here where x is 0. So y is equal to 2, That's not right. Y equal to 2 multiplied by 0 minus 1, which is 0 minus 1, and that gives you negative 1. So you can see that the point works. Here's a final example. Find the equation for the line represented by the table below. The first thing we're going to do is pick any 2 points for our slope. I'm just going to pick the first 2 points. So I got 2, 3. I got 5, 9. Okay, so my habit here is x1, y1, x2, y2. So our slope, which is represented by m, is going to be first y2 minus y1 over x2 minus x1. So y2 is 9, y1 is 3, x2 is 5, x1 is 2. So we have 6 over 3, which is equal to 2. And now, just for the sake of variety, I'm going to pick a different point. Let's pick one that is maybe 8, 15. 8, 15 is going to be our point, 8, 15. And I'm going to label the points. We have x1, y1. Next, we have our formula, y minus y1 equal to mx minus x1. Don't forget, this is your slope right here. Let's call it slope. So let's substitute. Y minus y1 is 15 is equal to slope, which is 2, x minus 8. So we have y minus 15. We distribute the 2. It's going to be 2x minus 16. So we add 15 to both sides. So we now have y equal to 2x minus 1. Very interesting. So let's go ahead and test 1 point. I think that should be adequate. We're going to test 1 point here. And let's try 10, 19. So y equal to 2 multiplied by 10 minus 1, which is 20 minus 1, which is 19. So you can see that that point definitely works. In this lesson, we're going to learn how to use percent to find a number. I'll start off by reviewing percent with you and showing you how you can use the percent to find a number. And then we'll look at some examples together using the steps that I've highlighted. Now, percent simply is a fraction with 100 as its denominator. So if I have 49%, it's 49 and I need 100 as its denominator. Sometimes when I remember learning percent, one of the ways that I remember this is when I look at this 0 and then I see this line and 0, I always just looked at it as 100. That's kind of how I remembered it. And so it's stuck ever since I did that. And so 9.85% is 9.85, and then I need 100 as its denominator. So that's pretty much what, when you say percent, the number to the left of the percent is your numerator, and then 100 is your denominator. Now, how do we go about using percent to find a number? So the first thing you want to do is to create a fraction with 100 as its denominator for the number that is to the left of the percent. And then we're going to create a ratio relationship between the numbers and the percent, and we're going to solve for the missing number. Now, this may all sound confusing, so let's go ahead and use these steps to solve some examples together. So 42 is 30% of what number? So let's go ahead and start with 30 over 100 is going to be equal to 42 over what number? Let's make it x. All right, so you have, this is going to be equal ratios. There's a video on equal ratios already. So but I'll still use the equal ratios method to solve this together. So now we're going to say that because we're looking at equal ratios here, I'm going to use cross product, but I can go ahead and simplify 30% first. So I'm going to simplify this by just crossing out the zeros. So I have 3 over 10 equal to 42 over an unknown quantity. So now we're going to cross product. So that means I'm going to multiply in that direction. So I'm going to multiply 3 by x, and that's going to be equal to 42 multiplied by 10. So to isolate x, I'm going to divide by the number to the left of the variable, which is 3. So divide both sides by 3. So x is equal to 42 divided by 3. Let's go ahead and do that. 42 divided by 3. 4 divided by 3, we have 1. And then 1 multiplied by 3, we have 3. 4 minus 3, we have 1. We bring down the 2 here. 12 divided by 3, we have 4. 4 times 3, we have 12. Remainder is 0. So this is going to be 14 multiplied by 10, which is equal to 140. So that means 42 is 30% of 140. Let's try a few more examples. 45 is 75% of what number? So let's go ahead. 75% is 45 divided by a specific number. Let's use x again. What I like to do is let's simplify 75%. We're going to divide by 5. So we're going to divide both of them by 5. We have 15 over 20. We divide again by 5. Divide by 5. We have 3 over 4. So now we have 3 over 4 is equal to 45 over x. So we're going to apply our same cross product approach. So we have 3 multiplied by x equal to 45 multiplied by 4. So now we divide both sides by 3. And then we have 45 divided by 3 here. 45 divided by 3. We have 4 divided by 3. We have 1. 1 multiplied by 3. We have 3. We subtract. We're left with 1 here. And then we bring down a 5. 15 divided by 3. We have 5. 5 times 3. We have 15. And then a remainder of 0. So this is going to cross out 3 and 3. So we have x is equal to 15 multiplied by 4, which is equal to 15 multiplied by 4. 5 multiplied by 4 is 20. So that is 0. We carry 2 up here. 1 multiplied by 4 is 4 plus 2, 6. So this is going to give me x equal to 60. And so therefore, 45 is 75% of 60. Now 12 is 80% of what number? So let's go ahead and 80% of, so 80 over 100 is going to be 12 divided by a specific number. We replace that number with x. So let's go ahead and simplify 80 over 100. 80 over 100. Let's cross this zeros cross out. We can now divide by 2. And we're left with 4 over 5. So 4 over 5 is equal to 12 over x. So now let's go ahead and do our cross product. So this is going to give us, let's actually go to a different line. So 4 multiplied by x is 12 multiplied by 5. So we want to isolate x, so we divide by 4 on both sides. Divide by 4. 12 divided by 4 is 3 multiplied by 5. So x is equal to 15. So what this means is that 12 is 80% of 15. Now our final example, 84 is 3.5% of what number? So 3.5 over 100 is going to be equal to 84 divided by an unknown quantity. So what I'm going to do here is, first of all, we're going to simplify the percent fraction there. So it's going to be 3.5 divided by 100. Now, you have a decimal up here and you have one place after the decimal. So I'm going to multiply by 10 to get the decimal, because when I multiply by 10, I move the decimal to the right. So it's coming after the number. So I also multiply the denominator by 10. So I have 35 divided by 1000. This you can divide by 5, numerator and denominator. So we now have 7 divided by 200. So therefore, 7 over 200 is equal to 84 divided by x. So you can also see here that if I just because it's 0.5, I can multiply by 2 and also multiply the denominator by 2. Let me show you that. 3.5 over 100, you can also multiply this by 2 because it's going to make this 7.0 over 200. This is the best way to do it because it's the most consistent way to do it. This is if you're very familiar with decimals and knowing exactly that 0.5 is 1/2. So if you multiply by 2, that removes the decimal. But I would rather you use the method highlighted here by the asterisk. So now we're going to do a cross product right here. So 7 multiplied by x equal to 84 multiplied by 200. So we're going to divide both sides by 7. And then 84 divided by 7, if you know your multiplication tables, that should give you 12 multiplied by 200. So therefore, x is 12 multiplied by 2 is 24. Then we add the 2 zeros to the end. So therefore, 84 is 3.5% of 2,400. In this lesson, I'll be showing you how to use your knowledge of percent change to work with discounts. We're going to learn how to calculate discounts. To do this, I'll first off introduce or review the percent decrease. Then I'll introduce you to what the discount really means, and then how do you find the discount, and then we'll work on some discount problems together. So what is the percent decrease? The percent decrease expresses the decrease in value as a percent of the original value. So your decrease is always going to be your original value minus your final value, and that is because your final value is lower than your original value. And how can you express as a percent? You always need to pay attention to your starting point, because your percent is based on your starting value. So that is why you have original value minus final value. So another way of writing this, percent decrease, is the same as the decrease, which is your original value minus your final value divided by your original value. So your original value is your starting point. So you want to know it, you want to find out the percent from which in relationship to where you started from. So this is going to be your decrease percent. Is the decrease divided by original value multiplied by 100. Now let's look at the decrease, the percent decrease from 15 to 9. So we're going to, let's go ahead and look for the decrease. The decrease is going to be 15 minus 9. So it's going to be original minus final value, which is going to give us 6. Now we want to find out the percent decrease. The decrease with respect to what number? So the decrease is 6, but our starting point is 15, and then we multiply by 100. I can go ahead here and divide both by 3. So I'll get 2 and 5. I can divide 5 by 5, 1. 100 by 5, 20. And that's going to give me 40%. So this is a 40% decrease from 15 to 9. Now, what is a discount? A discount occurs when you have a reduction in price. For those of us who go to the store a lot, especially the departmental stores, you may see something like a sale. That is also that's also a discount. You may see something like 20% off. So those are signs that you have a discount. A discount can be represented as either a percent or an amount. So here, your discount is your original price minus your final price, because your final price is lower. Your discount percent is going to be your discount divided by your original price times 100. Then your discount percent is the percent, your discount actually, if you want to get a value, is your percent discount multiplied by the original price. And then your final price is going to be your original price minus your discount amount. So these are the different ways you can work with discount, either as percent. This shows you different ways you can look at discount, using the percent, using amounts, and so on and so forth. We'll look at some examples where we have to apply a few of these approaches, and I think it'll make some sense to you once we're done. So how do we go ahead to find the discount and the discount percent? We want to first find out what the original price is, and we want to find out what the final price is. So that's really how you identify discounts. You need an original price, you need a final price. You also you could need a discount percent. There are different variations of ways to represent discount. So let's look at step 3 here. To find the discount, we substitute the values here. So the discount is your original price minus your final price. What about the percent discount? We've seen this formula before. So your discount percent is, let me write it this other way. Discount percent is going to be your discount divided by your original price multiplied by 100. And then your discount is your percent discount multiplied by the original price. That will tell you the discount. And then finally, your final price is going to be your original price minus your discount amount. So let's go ahead and look at some examples and see how we can apply this. So a dress that typically sells for $80 is sold for $60. What is the discount given for the dress? So here we know that our discount is going to be original price minus our final price. So the reason why we do it this way, remember, is that your final price is always lower than your original price. So here, your discount is going to be $80 minus $60. So this is going to be a $20 discount. So your discount here is $20. Now, a shirt that typically retails for $120 is sold for $108. What is the percent discount given for the shirt? So let's go ahead and calculate the discount first. Our discount is going to be original price, I'm just going to use short forms here, minus final price. So this is going to give me $120 minus $108, and if you do this, it should give you $12. Now we want to find out the percent discount given. So the percent discount is going to give us, actually, let's go ahead and write formula. One thing I like to do is I like to present the formula first so that I know exactly my approach. And then anyone else who's looking at my work can also see the approach I'm taking, so that if I make an error, it's easy to pinpoint where the error happened. So the percent discount is going to be your discount divided by your original price multiplied by 100. So here our discount is 12, our original price is 120, and then we multiply by 100. So I'm going to 0 here is going to cross this 0 out. 12 cancels itself. So we're going to have 1 multiplied by 10, which is going to give us 10%. So there is a 10% discount if we sell for $108 what originally retails for $120. Okay, after the Christmas holiday, the supermarket gave its customer a 20% discount on all Christmas lights. If the original price of Christmas lights at the supermarket is $15, how much did the customer pay? So we want to first find out the discount. The discount is going to be our percent discount multiplied by price. Or let's call this original price. Okay, so our discount here is going to be 20% multiplied by 15. So I'm going to cross this out here, and then 10 divided by 5, I have 2. 15 divided by 5, I have 3. 2 divided by 2, 1. So this is going to be a $3 discount. So what is the final price? So remember that discount is going to be original price minus final price. So our original price is $15. Our discount is 3. We don't know what the final price is, so let me call that F. So let's come over here. 3 equal to 15 minus F. So we want to find out what is the actual amount that the customer would have paid. So let's go ahead and we can do some manipulation here. So I'm going to subtract 3 here, and then that's going to give me 0, subtract 3 here also. 0 equal to 12 minus F. I'm going to add F here, add F here. So F equal to 12. So our final price is $12. Another way you can look at it, which could be easier for you, is that if the customer was given a 20% discount, what did the customer pay? The customer would have paid 80% of the price, because 100% is how much the item costs, and then we subtract 20% from that, so you have 80%. So because you have a 20% discount, the customer only paid 80% of what the item was worth. So now your final price can also be 80 over 100 times 15. So we cross this out here. This is 4, this is 5, and then 3. So 4 multiplied by 3, you have 12. So just two different ways to look at things. Whenever you're doing math, always remember that it's possible that there could be more than one way to get to the answer. So final example here is for the back to school shopping season, school supplies were discounted at a rate of 40%. So let's do this, discount percent. So we have 40%, so 40%. A customer purchased a bag of pencils or a pencil bag for $3.60. What was the original cost? So now we have two ways to look at this. One way is to identify that if the discount is 40%, that means that the customer pays 60% of the value. Customer pays 60%. So 60% of an unknown value, let's call that X, is going to be equal to $3.60. So now we can simplify 60%. Let's divide this by 20. We have 3 and 5. So 3 over 5x equal to 3.60. So now we can do a cross product here. So this is going to be 3x over 5 equal to 3.60 over 1. So let's go ahead and do a cross product here. So we have 3x is equal to 5 multiplied by 3.60. So 3x is equal to 18. And now we can divide both sides by 3. And then x is equal to 6. So the original cost of the item was $6. This is most likely the easiest way to do this. If there's another way to do it, but it'll take you quite a while to complete. So I'm going to show you this method because it's the best way to do it. And this is the least confusing approach to this. So at the end of this all, you can see that with discount, there are lots of different ways to look at discount. And an important thing for me as I work with discount is to always remember that when you have a discount, then you're paying 100% minus that discount value as a customer. So remember, in this case, because we have a discount of 40%, the customer is paying 60%. So now you can work with 60% as what the customer is responsible for. Hello, Unduka here from Math is Tutors. I'm here to announce a special campaign that we're about to kick off. It's the 5,000 Students for Math. Here's what the campaign is about. We want to find 5,000 students that fit into any of these categories. Are you a student struggling with math today, or a parent of a student struggling with math today, and you want to help build confidence in your students' math abilities? The campaign is for you. Are you a student that is actually feeling comfortable about math, but you want to go a bit higher? You want to build your confidence level a bit higher? This campaign is for you. Are you an excellent student, but you need a challenge? This campaign is for you. We want to get 5,000 students so comfortable with math that they've built a good foundation for their future academic pursuits. Now, are you interested in joining us in this campaign? We invite you, we welcome you to join us in this campaign. How can you help us with this campaign? Share this video with as many people as possible, and we hope to see students sign up because we want to see every student become comfortable enough with math that they conquer their fear of math. Please join us, and I'm sure you will enjoy the result of this campaign. Thank you.